So, as the test showed, DTek, and I have to admit this is an older DTek, and but it was never able to pick up the reference leak, which appears to be around 300 parts per billion. And there's not too much left, but it still has pressure. The reference leak leaks to a membrane there. DTek 24 parts per million sensitivity in R22, H10 about 0.3 parts per million sensitivity. So the H10 is 75 times more sensitive than the DTek for R22. R410 is a different story. There'll be another video on that. Okay, this balloon has 250,000 cc. I'm going to add 2 cc of R22. That's going to give me 4 parts per million, actually 8 parts per million concentration of R22. Okay, to rule out cross-contamination of the hoses, I installed a second hose, put some putty there. So we still got 8 parts per million R22. I've verified that the second hose does not set off the leak detector. Now you can see 8 parts per million easily sets off the H10 as a rather large leak. Okay, now I got the DTek warmed up. Let's see how the DTek does 8 parts per million R22. Nothing. Blowing it right into the sensor. Not in the sensor. Right in. So at 8 parts per million, nothing. So I'm going to go ahead and take up the concentration. Okay, now to figure out where the DTek picks up R22, I'm going to progressively increase the concentration. First I'm going to do 1 cc for the hose. Now I'm going to add 2 cc. It's taking me to 16 parts per million. Shake up the balloon. Get it mixed in there good.
I see a little pink feather on the balloon.
Again, 16 parts per million. DTek. Sometimes it misses it. They're barely getting 16. Yeah, barely getting 16 parts per million. R22. I might have had some cross-contamination when I injected. It's probably more realistic now. I'm going to add in another 2 cc to give me 24 parts per million. 1, 2. Shake it up and get it mixed around. It tends to be more sensitive right at the beginning. There we go. So 24 parts per million. DTek's working pretty good. shake it up a little more. So I would say the DTek's at 24 parts per million. I'm going to retest with the H10 since I started at 8 parts per million and the H10 was setting off like crazy. I'm going to deflate this balloon and re-inflate with air to get the concentration down to 1 part per million. Okay, I've got a trick here to add 1/3 of a cc. Basically have water in the syringe and I'll add the refrigerant and then flush the rest with water. So right now, push in 1/3 of a cc, flip it, run the water down the syringe. There we go. Added. So now I should have 1 part per million in the balloon. Shake it up. Warm up the H10. We'll see if we can pick up 1 part per million. I'm running the sensor a little bit cold. I might warm it up. All right, so here we are, 1 part per million. You can see the H10 easily picks it up. So I'm going to deflate this balloon to 1/2 the volume and then reflate it, and I will take it to half. Actually, I'll 1/3 the volume and then reflate it. That would give me 330 parts per billion. Okay, so to dilute down to, I was at 1 part per million. I took the volume of the balloon down by a factor of 3. So this will give me 300 parts per billion, and then I'm going to test with that. Okay, so now that I've diluted down to 300 parts per billion, let's see how the H10 does. Just barely picking it up. So at 300 parts per billion, or 1/3 part per million, the H10 picks it up just barely, but notice my calibration leak is not very sensitive. This sensor is a little bit older. I'm going to turn up the heat a little bit. Quite a bit more sensitive at 300 parts per billion. And now I'll turn up the sensor a little bit more. So when you run the sensor hotter, you get the calibration leak. It's easily sensitive to 300 parts per billion. Versus, remember the D-Tek Select, it was about 24 parts per million. So we're talking a factor of 75 times more sensitive with the H10. But this is on R22. R410 is a totally different story.